Hi everybody, Patrick here from EngineeringShot.com, ElectronicLessons.com, and PaintballProps.com. This is project number 7 for our multi-project electronics learning board. And today we're going to drive a 7-segment display. We're going to drive it using a 555 timer oscillator in Astable mode, 74LS93 decade counter, 74LS47 7-segment to a 7-segment decoder / driver to our common anode 7-segment display. Now this is a block diagram. I've got 11 tutorials below that go over the entire set of the electronics learning board. There are 11 blocks on the learning board. There are 11 tutorials. There's a tutorial for the 555 timer in Astable mode, a tutorial for the 74LS93 decade counter, a tutorial for the 7-segment decoder driver, and the common anode 7-segment display. So in this video we're going to show you how it all goes together. First things first, I want to connect the Astable pin on the board, AST, to my LED pin. And so we'll do that. And so every time the output pulses high, 5 volts, the LED will light up. There's a 390 ohm resistor here to limit current to the LED. The output of the 555 timer can actually output quite a bit of current. So if you don't protect the LED is going to say, okay, I'm going to take all the current you can offer me, and it's going to burn out. Trust me, I've done it. So anyhow, we can adjust the frequencies by tuning our RA and RB potentiometers. Watch the tutorial on the NE555 listed below in Astable mode. Anyhow, so we'll tune this so that we get about a 1 Hz pulse. So that 1 Hz means that the LED will be off, then on. 1 cycle for 1 second. This would be the equivalent of 1 Hz. Between here and here would be 1 second. So we don't have to get it to be tuned perfectly. This is just around what I want to tune it to. You'll see this in a minute because we'll be using this LED as an indicator. Once we're done that, once we've set our frequency, we're going to connect our Astable pin to our 74LS93 decade counter. Now there's 2 things to note about the decade counter. There's 2 pins labeled AND1 and AND2. Now they're labeled AND1 and AND2 on the board. In the data sheet they're actually labeled, I think, R01 and R02. We'll get to those in a second. It has 4 outputs labeled A, B, C, and D. They all have a binary weight to them. Output A has a binary weight of 1, B has a binary weight of 2, C has a binary weight of 4, and D has a binary weight of 8. So we can count from 0 to 15 in binary. 0, all the outputs are off. 15, all the outputs are on. 1 plus 2 is 3, plus 4 is 7, plus 8 is 15. So hopefully that makes sense. If it does not, you need to watch the tutorial listed below. Now, what happens when, again, we'll get to this in a second, but the idea is to have the binary representation listed on our 7-segment display. So what happens when we get to 10? It's a single display. What happens? Well, the 74LS47 decoder offers up some weird characters to the 7-segment display between a binary weight of 10 and 15. And they're really kind of ugly. They don't make much sense. They're kind of stupid to look at. I don't like it, so I'm going to have our device reset the instant the logic on these lines is 10. So in the case when D and B go high. So what will happen is the device will count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the second both of those lines are high, it will reset. So we will never see what would have been 10, what the character would be there, what character we would see there. And as well, say we wanted to, we wanted it to reset at 6, we'd see 0, 1, 2, 3, 4, 5, and we would not see 6. It would reset back to 0. In which case we would have to use B and C, 4 plus 2. Anyway, we're going to use D plus B, because 8 plus 2 is 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, instant reset of 10 back to 0. So what we have to do is we have to connect D to one of these lines, and B, C, D, to another one of these lines. Doesn't matter which one. It's an AND gate. If both of these lines are high, instant reset on the 74LS93. Hopefully that makes sense. It'll make more sense if you watch the tutorials. I hate to keep pushing the tutorials below, but they're very important for you to understand the theory behind the learning board. It's very practical. Anyhow, 74LS47 decoder, it's already hooked up on the board. You don't have to do anything special with it. It's connected to a resistor network, which isn't seen here because this is a block diagram. The resistor network is between the 74LS47 and this common Anode 7-segment display. Again, it has its own tutorial. That is used to that resistor divider between this bus is used to protect each of the LED segments. So the 74LS47 decoder takes the binary logic based on the A to D outputs from the 74LS93. It changes it into, it decodes it so that it can drive all of the 7 segments. So segment 1, 2, 3, 4, 5, 6, 7. They're actually labeled segment A, B, C, D, E, F, G. And if you watch the tutorials, you'll see how that works. So again, once we have all that set up, it should count at a frequency of roughly 1 Hz. So it should go 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, reset back to 0, and keep going. So we're actually going to do a neat project next using claps. We're going to count claps in our next project. But this is just the introduction to using this to create pulses, this to count upwards in binary, this to decode the binary information, and to drive the 7-segment display. This is our trusty LED indicator. Let's put this on the board. I've plugged in my 9 volts via my transformer here. Plugged into a wall transformer. This is a 7805 regulating down to 5 volts. This is our 555 timer in Astable mode, and this is RA and this is RB. It's labeled on the board, but I know it's very difficult for you to see. So what we need to do is we can adjust these 2 potentiometers to output a different frequency. But to see that frequency, what we need to do is connect the output of the 555 timer to our LED. So first things first, what I want to do is I want to connect the Astable pin, which is right here on the board, to my LED pin, which is right here. So that's the pulse. Let me just turn off the light for a second. That's the pulse that is creating right now. The duty cycle is very different. It's on longer than it's off. So I can fiddle around with it. Let me fiddle around with RA and RB and we'll see if we can manipulate that signal. So I'm just going to take my screwdriver. Sorry if I obstruct the view, guys. So I've turned RA left a whole bunch and turn RB left a whole bunch. One Mississippi, yeah, 1 Mississippi, 2 Mississippi, 3 Mississippi. So that's good. Now we're about on as long as we're off, so our duty cycle is roughly 50%, sorry. It's on for the same amount of time it's off, roughly. Not a big deal. Now, what we're going to do now is there is a little 2-pin header right here that's labeled EN. And your learning board will come with a few 2-pin header jumpers, and this will power the 7-segment display. Now, what we're going to do now is, as we talked about in the video, we're going to take this off the LED, the Astable output, AST output. We're going to put that in the clock plus pin. Now, you might be wondering, why isn't it counting yet? Do you remember those AND pins, AND1 and AND2? Right now, those are left floating, and they're located right here. Now, what's floating, do you ask? I'm glad you asked. Floating is when you don't have it connected to a signal line or 5 volts or ground. It's just left connected to nothing. And when it's left connected to nothing, the 74LS93 thinks, okay, well, they're both at 5 volts. So it's in constant reset mode. So what we have to do is we have to make our connection. So I'm going to connect the AND1 to our out D, which is up at the top. And I'm going to connect my AND2 to my out B. So let's watch this. Let's see what happens. It should reset once it hits 9 or 10, but you won't see 10. See? Now, what happens if I leave one of the lines floating? It's going to continue to count up to 15. Or, sorry, I'm going to ground this. I have to ground this. There's a ground plane right here on the left side of the board. Sorry if you haven't been able to see this. 9, 10, 11, 12, 13, 14, 15, reset, 0. There we go. I've switched my AND gates, my AND, who's 1 and AND 2, back to output D and output B. And now I'm going to be turning my potentiometers, my RA and RB potentiometers right. And that should speed up the frequency. Pretty neat, huh? To the point where we probably won't even be able to see it. It'll be counting too fast. It'll just look like an 8. Anyhow, that is driving our 7-segment display. We've got our oscillator creating each pulse, which increments. We've got our 74LS93 decade counter, which counts it from 0 to 15 in binary. We've got our 7-segment display driver, our 74LS47, and our common anode 7-segment display. Thanks for watching, guys. Next video, we're going to use our microphone and our amplifier to basically, and our monostable multivibrator to count claps. We're going to go 1. It's going to display 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Anyhow, we'll get to that. Video coming soon. Thanks for watching.